Hello everyone, my name is Natarajan. I'm working as a scientist at Society for Electronic Transactions and Security, Chennai, India. In this video, I'm going to present a poster which is accepted in Qcrypt 2022 titled Aggregation of Tokenized Signature Scheme and its Application. First, I would like to thank the organizers of this conference and my co-author, Prem Laxman, Senior Scientist at Society for Electronic Transaction and Security, Chennai, India. So, in this poster, we are going to present an aggregated tokenized signature scheme, which is a base scheme which evolved from the quantum money concept. So, in classical cryptographic, digital signature schemes are uh, has many important applications. So, in the classical setting, it is very difficult for authority to delegate powers to sign the uh, documents. So, because the public key cryptographic settings, it based on the secret key and private key. If you share the secret key with the user, it's very difficult to trace, and it is more vulnerable. So that's where the tokenized signature scheme being proposed, and it is based on the quantum tokens, which solves many of these problems of sharing a secret key. And aggregated verification signature scheme is another scheme which helps to reduce the verification time and signature length. So in this scheme, we are trying to combine these two aggregated verification scheme and the tokenized signature scheme and construct a new mechanism which can more powerful and used for many applications. So the major problem here we attempt to solve is, can we construct a tokenized signature scheme which allows to aggregate and verify. The major contributions of this paper is, one is the primitive construction of aggregated tokenized signature scheme, and examine this tokenized signature scheme can be used to construct aggregation, and what are the advantages and applications of these tokenized signature schemes. So let us look at the scheme. So formally, the tokenized signature schemes, as I said, it is all based on the quantum tokens, wherein the authority can generate a key pair, a private key and public key pair, and using his private key can generate tokens. That tokens can be delegated in terms of powers. So this resolves a problem of exchanging the secret keys to signers. Another thing is, the signer of the message may not be aware of the information, secret key information of authority. So this can be achieved via quantum tokens. So the formal construction of tokenized signature scheme is basically a collection of five quantum polynomial time algorithm. One is key generation and the token generation. Third is signing, verification, and revoke. So keygen is a quantum polynomial time algorithm which takes a security parameter of string and then outputs the secret key and public key pairs. So token gen takes a secret key and produces the set of signing tokens, which is a quantum states in nature. And the signing process, the signer takes input message and the quantum signing token and outputs the signature. So in the verification end, the message and the public key is being used to verify whether the signatures can be accepted or rejected. At the revoking end, the unused tokens, quantum tokens, can be revoked using the public keys. or else if their the authority wants to revoke, get the uh, rights back, can use these revoke options. So this quantum tokenized signature scheme based on aggregation construction, which is basically preserves the property of no cloning theorem, where the signer cannot produce the quantum tokens by his work, because it's all generated by the authority. So if the signer gets n tokens, he can only sign n documents, not n plus 1. That means this preserves the cloning property. So unused tokens, as I said, it can be revoked. So how to aggregate these tokens? So now the signer signed the uh, message using the quantum tokens. How to aggregate that? So the aggregation is aggregated signature scheme is being constructed based on two adding a two extra quantum polynomial time algorithm. One is the aggregation module, signature aggregation module. So another one is the verification module. So the signature aggregation module, which takes the input message and the signatures corresponding public keys to generate aggregated tokenized signatures. So this tokenized signature outcome can be easily verified by the verifier using the input message and the finally aggregated combined signature using the public key. Then the signature verification module outputs whether the signatures are accept or reject. So let us look at the high level overview of how this scheme works. So the basically the authorities, there might be n authorities which can produces the pair of keys, which is public pk1 public key and secret key sk1. In addition to that, there is a model a token gen module where which consumes the secret key and produce this set of tokens. These tokens can be issued to the corresponding signer where the signer can sign. At the signing stage, the message and the tokens are being used to sign the message. Then they finally it produces S1, which is a signing outcome. So, likewise, we can produce these signing signatures. These signatures, along with the message corresponding public key, can go into the aggregation module, where you can aggregate and produce a single signature. So, this signature is a compressed one. This can be easily verified by verifier instead of going each and every signatures. So this verifier, aggregator verifier will provide whether accept or reject a 0 or 1. Based on that, we can we can verify all the signatures at one go. So possible construction is this scheme is aggregated signature scheme, which is based on the reference 3, which talks about the IO of subspaces, where the authority has IO construction, which is based on the subspace A in F2 over N and the selection of secret vectors S and S prime. Based on that, he can construct IO A plus yes as a one IO. Another IO is A prime S plus S prime. So these two IOs where signatures can be measured with standard basis. So that means it basically a coset state where you can perform measurement accordingly. If it goes to the coset 1, then you say 0, or if the measurement goes for coset another coset, the message is 1. So likewise, you can construct the scheme. And finally, the aggregation is based on the membership module, and the verification also based on the memberships. So finally, if you construct different cosets and the different animal, and the signatures can be aggregated easily. And the verification also, the user takes the final outcome of the aggregated signatures and use this circuit for verification. So the major advantage of this scheme is it it reduces significantly verification time and the bandwidth. And number two is, so it is easy to incorporate with any of these kind of delegating power schemes. So here is the major example is the blockchains and the cryptocurrencies, where in blockchain there are multiple transactions being carried out at or a single authority or multiple authority. Those transactions can be verified using this aggregated verification instead of going for verifying block by block. Similarly, for cryptographic cases. So this scheme, aggregated verification tokenized signature scheme, can be major functionality to delegate the power to signers in many scenarios. And this authority of these tokens can periodically audit and monitor these signing things, and it is easy to incorporate with any of the existing crypto public key signature schemes, and it can be easily verified at a single shot. With this, I would like to conclude this tokenized signature scheme and aggregation is an emerging one, and it is construction is based on the quantum money schemes. So with this, I would like to thank for the opportunity. These are like few references. Thank you.